Here's a little optics demo that I think is really cool. I'm sure most of you have seen a pinhole pattern before from a laser. If not, you might want to look it up on Wikipedia. But what I have here is a laser, red laser, and it goes into a microscope eyepiece, and that just blows up the laser beam, so it's a nice big round dot. And then this little camera lens cleans it up. And then I'm shining it on a slide, and that slide has a picture of Einstein on it. And the picture is made in the same way that newspapers make images, so it's a bunch of dots. And you can think of each one of those dots as being like a pinhole. So what happens after the laser hits the image of Einstein, I'll show you it's hitting an image of Einstein. Not very good, but we'll see. Come on. So you can kind of see there's a face there. So what's happening is immediately after the laser light goes past this image, all those little pinholes, all those little dots that make up the image are acting like pinholes and turning the laser beam, or turning the light into a bunch of pinhole images. And what happens, I've got this lens here, and what it's going to do is it focuses those pinhole images into its focal point. And it's kind of hard to see. Actually, it's really hard to see, especially on this camera. But all those pinhole images come out and they stack up on top of each other into this pattern of dots. And you can't tell what the image is, but it's what's called the fourier decomposition of the image. And what that means is that all the little details like his hair and maybe freckles, but that's not going to show up on the image, but any small details in the image are going to be represented by small dots, which are going to make large fringe patterns, large pinhole patterns. So if you have a small dot, you've got large fringes, and if you have a large dot, you have small fringes. And anyways, all those patterns are stacked up on top of each other here, so you can't tell the difference between them. But each of the different patterns carries information about different aspects of the image. The finer patterns are represented by different pinholes than the larger patterns, so the contrast of the image is split up into waves. I know I'm not doing a great job of explaining it right now, but it's kind of off the cuff. Anyways, the cool thing is that this lens turns this dot pattern back into the image of Einstein. After this focal point here, where all the waves are stacked up on top of each other, they spread out back again and they recombine to reform the original image. Let's see if I can get that to focus. See? And you can kind of see shape coming out again. And there's Einstein, made out of all those little pinholes reconvolved, I guess you'd say, or convolved. But I can take this lens out of the way and you can get a much better idea of what that fourier decomposition looks like, because the lens won't refocus it and the pattern will continue to spread out. So right here you still have kind of a decent image of his head. It doesn't look that way through the camera, but it's pretty decent. And then after this point, the image starts to spread out again. Oh, let's just take it all the way to the wall. So it may not look like it, but this pattern of dots completely represents all the information in the original image of that Einstein head. And if you put a lens in the way, all those overlapping pinhole patterns would spread out again and recombine at some point to make the original image.